In the world of space exploration, one of the most critical pieces of technology is the rocket engine. Without an efficient and reliable rocket engine, humans wouldn't have been able to explore beyond the limits of our planet. The National Aeronautics and Space Administration, NASA, has been at the forefront of rocket engine technology for decades. However, with the increasing demand for more powerful and efficient engines, NASA had to reinvent the rocket engine to meet the requirements of the modern space age. In this video, we will explore how NASA reinvented the rocket engine to be more powerful, efficient, and reusable. But before that, let's talk what makes NASA more special than other space programs. NASA, the National Aeronautics and Space Administration, is a government agency dedicated to space exploration and scientific discovery. Since its founding in 1958, NASA has accomplished countless milestones in space exploration, from landing humans on the moon to sending probes to study the far reaches of our solar system. We will explore what makes NASA so special and why it is such an important organization. One of the key factors that makes NASA special is its use of cutting-edge technology. NASA has been at the forefront of developing new technologies and methods for space exploration, from advanced propulsion systems to robots that can explore other planets. This technology has enabled NASA to push the boundaries of what is possible in space exploration and has led to many groundbreaking discoveries. NASA is also known for its ability to collaborate with other space agencies and organizations around the world. This collaboration has allowed NASA to share knowledge, expertise, and resources with others, leading to many successful joint missions and scientific discoveries. This global collaboration has also helped to foster international cooperation and diplomacy. NASA is dedicated to advancing scientific knowledge through its space exploration missions. From studying the origins of the universe to exploring other planets, NASA has made many important scientific discoveries that have advanced our understanding of the world around us. This commitment to scientific discovery has also helped to inspire future generations of scientists and explorers. Perhaps the most obvious factor that makes NASA special is its role in space exploration. NASA has sent humans to the moon, explored other planets and moons in our solar system, and even launched probes to study the edges of our universe. These accomplishments have captured the imagination of people around the world and have helped to advance our understanding of the cosmos. Finally, NASA is special because of the inspiration it provides to people around the world. NASA's missions and accomplishments have captured the public's imagination and inspired people to dream big and pursue careers in science, technology, engineering, and mathematics, STEM. NASA's commitment to public outreach and education has also helped to promote scientific literacy and inspire the next generation of scientists and explorers. The rocket engine dates back to ancient times when the Chinese used rockets for military purposes. In modern times, rocket engines were used to propel missiles and eventually spacecraft into space. NASA began using rocket engines in the 1960s during the Apollo missions, and the engines have undergone significant transformations since then. The traditional rocket engine used chemical reactions to produce the energy required to launch the rocket. The fuel and oxidizer would ignite in a combustion chamber, producing high-temperature, high-pressure gas that would shoot out of the rocket nozzle, propelling the rocket forward. However, this method of rocket propulsion had several limitations. First, the traditional rocket engine was not very efficient. A large portion of the fuel was burned in the combustion chamber, producing exhaust gases that were not useful in propelling the rocket. Second, traditional rocket engines were not reusable. Once the fuel was consumed, the engine would detach from the rocket, and a new engine would need to be installed for the next launch. This made space launches very expensive and unsustainable. NASA recognized these limitations and began research into new rocket engine technologies. The first breakthrough came in the form of the Space Shuttle's main engines. These engines used a reusable design that allowed them to be used multiple times, reducing the cost of space launches. However, NASA continued to seek more efficient and powerful rocket engines. In the 1990s, NASA began working on a new type of rocket engine called the Aerospike engine. Unlike traditional rocket engines, the Aerospike engine used a bell-shaped nozzle that was open at the bottom, allowing it to adjust to different altitudes and atmospheric pressures. This design allowed for more efficient fuel consumption, reducing the amount of fuel needed for a launch. In 2004, NASA tested the Aerospike engine in a wind tunnel and found that it was 20% more efficient than traditional rocket engines. However, the Aerospike engine was never used in a space launch due to budget constraints. The next breakthrough came with the development of the RS-25 rocket engine, which was used in the Space Shuttle program. The RS-25 engine used a unique design that allowed it to be reused up to 10 times, reducing the cost of space launches significantly. In addition, the engine used a regenerative cooling system that allowed it to burn fuel more efficiently, further reducing the cost of space launches. NASA continued to push the boundaries of rocket engine technology with the development of the J-2X rocket engine. The J-2X engine was designed to be used in the next generation of NASA's space exploration program, the Constellation program. The engine used a new type of fuel injector that allowed for more efficient fuel consumption, producing more power with less fuel. However, the Constellation program was canceled in 2010, and the J-2X engine was never used in a space launch. NASA is currently working on several new rocket engine technologies that could revolutionize space launches in the future. One of these technologies is the Solar Electric Propulsion (SEP) system, which uses solar power to produce electricity that is used to power an ion engine. Unlike traditional chemical rocket engines, ion engines use electricity to accelerate ions, which are propelled out of the engine to produce thrust. This system is much more efficient than traditional rocket engines and can be used for long-duration space missions. Another technology NASA is exploring is the use of 3D printing to manufacture rocket engine components. 3D printing allows for more complex shapes and designs that can improve the efficiency and performance of rocket engines. In addition, 3D printing can reduce the manufacturing time and cost of rocket engine components. The rocket engine is an essential technology for space exploration, and NASA has been at the forefront of its development for decades. Through research and innovation, NASA has reinvented the rocket engine to be more powerful, efficient, and reusable. From the Aerospike engine to the RS-25 engine and the J-2X engine, NASA has made significant strides in improving rocket engine technology. The future of the rocket engine looks promising with the development of new technologies like the Solar Electric Propulsion System and 3D printing. With these advancements, space exploration will become more accessible, efficient, and sustainable, paving the way for human exploration of our solar system and beyond. What next can we achieve in space exploration? The potential for space exploration is endless, and there are several exciting initiatives and projects underway that will continue to push the boundaries of what we can achieve in space. Here are some of the things that we may achieve in the near future through space exploration. Human exploration of Mars. Several countries and private companies have set their sights on Mars as the next destination for human exploration. NASA plans to send astronauts to Mars in the 2030s, while SpaceX has ambitious plans for a Mars settlement by the 2050s. Search for extraterrestrial life. The discovery of life beyond Earth would be a major scientific breakthrough, and several missions are currently underway to search for signs of life on other planets and moons in our solar system. Space tourism. As the cost of space travel continues to decrease, it is likely that space tourism will become more widespread. Private companies like Virgin Galactic and Blue Origin are already developing spacecraft for suborbital space tourism, and there are plans for orbital space hotels in the future. Asteroid mining. Some asteroids contain valuable resources like water, precious metals, and rare earth elements. In the future, it may be possible to mine these resources and use them to support space exploration and other industries. Space-based infrastructure. Satellites and other space-based infrastructure are essential for communication, navigation, and weather forecasting, among other applications. In the future, we may see the development of new types of space-based infrastructure to meet emerging needs, such as space-based solar power systems. Overall, the potential for space exploration is vast, and we are likely to achieve many incredible things in the coming years and decades as we continue to explore our universe and push the boundaries of what is possible.